All right. Well, it's just a little bit after 7, so I think we can go ahead and get started. So, good evening, everybody. My name's Jessa Frost. I'm the program director at a little place called North House Folk School. And my hope is that many of you have had an opportunity to visit us in Grand Marais, Minnesota. But for those of you who haven't, we are a little school located right on the edge of Lake Superior, just about an hour south of Canada. So as far as the continental United States go, we are nearly the end of the road. And we've been around for going on 24 years now. And what we do in non-pandemic years is teach people traditional Northern crafts. And so that can mean a lot of different things, everything from baskets to mucklucks to boat building and blacksmithing and shoemaking, jewelry, folk arts, lots and lots of different things that folks that have cultural traditions and roots in Northern cultures that we gather instructors and students together to learn. And during a pandemic, that gets a little more challenging. And so we've made a move towards offering more digital programming in the hopes that we are able to continue to carry out our mission of enriching lives and building community through the teaching of traditional Northern craft. And there's been some really wonderful silver linings to that, which is that lots and lots of people can join us, 150 some people on a Thursday night in December. I can tell you, not only would 150 people not fit into the Blue Building on a Thursday night, that would be a stretch for Grand Marais in December. It's pretty quiet up here. But one of the crafts that we really enjoy teaching at the school is Northern ecology and anything that helps us connect to the landscape and to the great outdoors. We talk a lot about how if you're going to harvest birch bark to make a canoe or a basket, you have to really understand the tree and the seasons and the landscape before you can even think about harvesting that material. And so something like astronomy is part of that keen observation of the landscape. North House is located on the lands of the Anishinaabe people, and we know that Anishinaabe practiced and continue to practice astronomy as part of their of knowing when to move during and when to move camp and when to harvest different things. And so this is a craft that is deeply rooted in the Northern landscape. And so I'm really delighted to have Bob King with us tonight, who has been teaching at the school for a few years, usually a class in person, but also been studying astronomy for years since he was a child because he loves it and is passionate about it. And so Bob is an amateur astronomer and author of several books, and we are delighted to have him with us this evening to tell us a little bit about what we can all see out our windows these days. And so the way a webinar works is that we're going to let Bob give a presentation. We're going to ask you to hold your questions until the end, but you can take advantage of the little function called the Q&A button at the bottom of your screen to put your questions in if you think as you go, and then we'll go back and ask them at the end. You can also use the chat for questions, but Q&A is great because if they come in really fast, we don't lose them. So with that, I think I'm going to turn things over to Bob, and just a quick acknowledgement of the many wonderful donors and supporters of North House and foundations that make this kind of work possible, have allowed us to stay in business and continue to provide this programming. So thanks to all, there are many of you I can see in the audience right now. So thanks to everybody. And Bob, tell us what's going on out there.
Thank you. Thank you so much, Jessa, for that introduction. Great to be here. I'm in my bedroom here in Duluth, Minnesota. The sky, I think, is partly cloudy. And of course, I'm always hoping, like you are, for clear skies when there's special events. As Jessa mentioned, I'm an amateur astronomer. I think I got interested when I was about age 10 or 11. And now I'm an old guy, and I'm still hooked to the sky. It is a really crucial part of the landscape around us. Just like knowing the flowers and knowing the trees, knowing the stars puts you in touch with the earth. And it provides not just inspiration and knowledge, but solace as well. Many things have changed in the past year, but the night sky has always been there for us. And it's a wonderful place to go to sort of rediscover calm on some occasions, and also to reawaken or restore your sense of wonder if you feel slightly damaged this year. So we're going to talk about a few things that you can see, that we'll see in the coming weeks. My gosh, the year is almost up. We've only got a couple weeks left. And interestingly enough, it is going out with a bang. We have some wonderful events, all of which you can see with your naked eye. And I'm going to start here with something I bet you have seen outside your kitchen window. And that is, you see what's between the two hands there? I bet you already know what those are. Those are the planets Jupiter, the bright one here, and above it, Saturn. And those two planets have been getting closer and closer and closer together. We'll talk about them in just a minute. This was last night, just before the clouds came in. I went out with the camera and my daughter, and I said, could you put your hands up there and see if we can frame those planets? And she did, and then the clouds came. First, we're going to talk about what's coming up more immediately, and that is the best meteor shower of the year. It is called the Geminid meteor shower, and it's called the Geminids because the meteors will emanate or shoot out of the constellation of Gemini the Twins. You might be familiar with Gemini the Twins. It's one of the zodiac constellations. The shower is active for several weeks during December. Even now, if it's clear tonight, you could go out and you could see a couple of Geminids, maybe 5, maybe 8 per hour, thereabouts. But the shower will peak on Sunday night, December 13th, into the morning, on Monday morning, the 14th. This picture here, which was taken in Spain, shows an observatory, and it's a composite image of many photographs of many Geminids, all composited into one to give you that sense of it being a shower. Now, the Geminids all will appear to radiate from the very same spot in the sky. And of course, it's called the radiant. That's the official term for where meteors stream out of. And that radiant is located right here near one of the Gemini twins named Castor. There's his brother, Pollux, right down below. The Geminids is a very interesting shower for several reasons. One of the best is that you can go out early to see the meteors. You've probably been familiar with other meteor showers where you'll read or someone will say, oh, it'll be best, but you got to go out at 2 o'clock or 3 o'clock in the morning. And you're like, oh my gosh, I work. This is really hard for me. But the Geminids, in contrast, you can go out at around 9 o'clock or 10 o'clock in the evening, which is what makes this a really fun and very accessible family activity. And it's also a wonderful thing to do with friends. Maybe you haven't seen your friends in a while, but you can invite them over, ask them to bring their own lounging type lawn chair, and then you can socially distance space in someone's driveway, let's say, or you can find a place in the country where it's darker and you'll see more meteors. And then you just get all of your winter clothes on, you get underneath a nice warm wool blanket or a sleeping bag. I've done them both in the years. And lay back. Don't stand to watch a meteor shower. Relax and enjoy it. You can start watching the shower as early as 9 or 10 p.m. You will see more meteors, though, the later you stay up. But at least during that hour, the radiant is visible. It's in the eastern sky. And it's a good time to bring kids out if they've never seen a meteor shower. This view looks east, again around 9 o'clock. And there's Orion off to the right. And there's the radiant there off in Gemini. Now, you may read that you can see 125 meteors per hour in this shower. And maybe you can if conditions are ideal. You're right in the middle of a desert, not a single light, and that point in the sky where the meteors come out, that's right overhead. But more realistically, we all live in places where there's some degree of light pollution. There's light domes here and there on the horizon, and that light pollution tends to rob us of the fainter meteors. So I like to take these shower numbers and cut them in half. And when you do that with the Geminids, you get down to about 50 or 60 per hour, which, trust me, is plenty. It is the richest shower of the entire year. You may be familiar with the Perseid meteors in August. This is richer. It has more meteors than that shower. There I am. I couldn't get anybody to join me this night. This was back in 2018 for the Geminids. Now my two daughters are going to be joining me for the current shower here on the 13th. At least I hope so. Sometimes the Geminids are tough because it's cold outside compared to the other showers. But if you dress properly, you really get ready, like you're going to go ice fishing. That's about the best way to do it. You get a good blanket, you lay back, you're in good shape. One of the coolest things about a meteor shower is that you do not need any equipment. You just go out and use what you were born with, just your eyes. And you can lay back, you can relax. You may even fall asleep while you're out there and then wake up suddenly. And then look at the meteors. You might want to set yourself a goal even and say, well, I'll stay out about an hour or maybe an hour and a half. And that's a good amount of time to lend to a meteor shower. Maybe even a number like, maybe I'll see 30 and I'll go in after I see 30. I do that. I have to tell you a little secret. I do that. And then when I hit 30, inevitably, I wait for a 31 and then a 32. And then I figure, well, I might as well go to 35 as long as I'm out. It's that sense of anticipation that I love. And showers, meteor showers can be a little funny. Sometimes you'll see two at the same time, two flashing meteors, and then there'll be a quiet spell of 3 to 4 minutes, and you think, well, this is over. And then it'll just start right up again. So there's a certain cycle to this or feel to it where if you plug into it, you really become part of the event. So just take it easy, relax. I would recommend for the shower, if you go out in the evening hours, 9, 10, 11, that you face to the southeast. You can face any direction. Geminids will appear all over the sky, but you'll know it's a Geminid and not a random meteor if you draw the trails back. Just follow them backwards. If they point down to Gemini, off to the left of Orion, then you know you got a Geminid. Two basic viewing times, 9 to 11, if you're going to go out in the evening, or you can go out after midnight, like from 1 a.m. to 5 a.m. Why would you want to go out after midnight when you can see meteors in the evening? The reason is the point from which they come, the radiant, is much higher up in the sky. So meteors flying out of that spot in Gemini won't be cut off by any horizon. They will have the run of the entire sky. Also, after midnight, and this is true for any meteor shower, as a matter of fact, for meteors in general, the Earth, as it rotates, and you can see it here in the diagram, we're looking above the planet, above the North Pole. Here's our observer. That's you right there. There's the midnight point. The Earth is turning in this direction. Do you see what's happening here? As the Earth turns in the direction of its motion, its orbital motion around the sun, it's actually turning to face head on into the meteor shower. That means they're going to come ping, 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 ping rather quickly, and there'll be more of them. Compared to watching the shower between sunset and midnight, when meteoroids, they're actually called meteoroids, by the way, before they appear in the atmosphere, the actual particles are meteoroids. And then they become meteors when they burn up. They have to catch up between sunset and midnight, so we don't see generally as many meteors before midnight as after. So you can take your pick, or you can do like what I do if you want. I kind of split the difference. I go out at around 10 or 10:30, and I stay up until 12:30, maybe later, as long as it's clear. And so you get a little bit of the evening, get a little bit of the morning. It's all good. Where do these things come from? I'm talking about meteoroids, right? These little particles in space. Well, most meteor showers come from comet dust. They're very tiny particles. This is a comet right here, a beautiful close-up. Look at this thing. It's roughly a kilometer across or so. It's made out of mostly ice, but the ice is all filthy with dust and little bits of rock and other ices and gases and such. So when that comet gets near the sun, what happens is that the sun's heat vaporizes some of that ice. And so it goes off into space and it liberates the dust too. And the dust falls behind the comet and forms a tail. This comet is called 67P Churyumov-Gerasimenko. Can you say that 10 times fast? This was photographed up close by the European Rosetta mission several years back. And here's a typical comet. This is what they look like from Earth through a telescope. We have a bright comet head. Deep inside there is the icy piece that you can't see from here, from far away. And here's the tail. And that tail is made of dust particles that reflect the sunlight. And that is the origin of most of our meteors. So when you go out on any average night, and most meteors are just the size of sand grains, like on the beach in Grand Marais or here in Duluth. Very, very tiny. But when they strike our atmosphere, these guys are moving so fast that they just incandesce. They glow white hot. And so they start to glow and become visible to your eye as they're streaking into the atmosphere. They also make the air around them glow. It's called ionization. And that ionization makes the glow too. So these two combined glows create that streak in the sky. So what you're really seeing is a bit of a comet vaporizing, heating up and burning up overhead. And that to me is just an amazing thing in astronomy, is that you can be so close to a comet, but only for an instant. Here's where the Geminids are different. Again, we talked about it being a shower where you could go out in the evening and see it as well as the morning. The Geminids do not originate from a comet. Instead, their source is a peculiar asteroid called 3200. All asteroids whose orbits we know about get a number. 3200 Phaethon. That is the source. And these pictures are interesting. These are actually radar images of the asteroid when it passed near the Earth. They were taken by the Arecibo Observatory in Puerto Rico. And you may have heard the news recently that that observatory collapsed, which was a really sad story. But before it did, it took many, many radar images of lots of different asteroids, including the source of the Geminid meteor shower. We know it's the source because we can determine the orbit of a meteor. We can see the streak and determine its orbit. And we can determine the orbit of Phaethon. And guess what? They match. So when you have a match, you find the source. Here's what's weird about Phaethon now. Look at this. Here we got Jupiter, Mars, the Earth, the sun in the middle. Phaethon has this looping orbit that takes it very, very close to the sun. Matter of fact, it only gets 13 million miles from the sun. I know that sounds like a really far distance, you know, when you're living on this little Earth of ours, but that's incredibly close, much closer than Mercury. And guess what happens to the surface of that asteroid? It heats up to like, I don't know, 1700 degrees, something like that. Hot enough that astronomers believe what's happening here is that it's causing the crust of the asteroid to crumble and crack and break apart into these dust motes and rocks. And that stuff spreads out behind the asteroid, just the way comet dust does when a comet's ices are heated and vaporize in sunlight. Look at that. What a beautiful illustration. Here we have the planets again. We've got the sun, Mercury, Venus, there's the Earth. Here's the orbit or part of the orbit of Phaethon. And this is the dust spread out behind the asteroid. There's the Earth. Every December, Earth's orbit intersects that of Phaethon. It goes right through that cloud of debris, streams right into it. And the next time it snows, and it has not snowed nearly enough here lately, and I hope it does soon so you can enjoy this. The next time it snows and you're out at night and you can see the snow in your headlights, look at what you're looking at there as you're driving. When you drive into a snowstorm, you are actually seeing a radiant, that same perspective effect. Remember I mentioned that meteors appear to radiate from a point in the sky? Well, that's because the Earth, just like your car, is traveling through a stream of debris. With your car, you're going through a snowstorm, and those meteors or the debris appears to make streaks. And we are heading into them, so though right in the direction we're heading, they're very short streaks. And further off, if we look to the sides, as you can in this picture of the snow, the streaks are longer. So that is a fascinating thing. That's why when you go out at night to watch a meteor shower, it's good not to look directly at the radiant point, because you'll mostly see just the short ones, like you saw the short streaks of snow. Look off about 45 degrees to this side or to that side. Then you'll get the shorties, and then you get the long ones too, a really nice mix. No need to worry about it either way. You can look anywhere you like, you're going to see meteors. But if you want that sort of mix, give that a try. Quarter turn either side of that radiant point, which is just a perspective effect, right? Is because we are plowing right through the trail of that dusty debris from Phaethon. What happens if it's cloudy on the 13th? This is always an issue with an astronomer, which is why I'm convinced we tend to be very optimistic folks, because we always have to believe that it's going to be clear. It's when we have to believe it right up until the moment when we have to confess that the deal is done and it's cloudy. Now, if it's cloudy on the 13th, you can still go out. You can go out tonight, next night. If you go out on the 12th or the 14th, you will see about a third as many meteors as you would see during the peak time. So I really hope you get a chance to see this beautiful shower. I hope it's clear and that you have an hour or so to give over to it, to relax. One of the other things is if you're out with friends and you're under the big sky, you get to see other things too, like satellites and Orion coming up. And inevitably, at least I've found, the conversation always becomes kind of cosmic. You know, you get a sense of where are we in this universe? And that's just the beautiful dressing that comes with a meteor shower. So if you're ready, we'll move on, because we have another really cool event. I bet a lot of you have been watching this. This is a conjunction. Very close. You can see right there, there's Saturn and Jupiter again, kind of like you saw on the very first slide. And you have probably noticed that those two planets are getting closer and closer and closer in the sky. When they reach their closest, when they're one right atop the other, we call that a conjunction. This was taken just a few days ago, and they're really quite a nice sight. Jupiter and Saturn are out in the evening sky, and they're best visible right now through the month of December, about an hour after sunset. Be sure you find a place where you have a nice open view to the southwest, right? Doesn't matter if the east is, you got a mountain there. As long as you've got that nice view low down into the southwest, you'll see this. And a good time is from 45 minutes to an hour and a half after sunset. Well, here's a conjunction. We have a moon airplane conjunction here. And what's happening? What's happening is that you, the viewer, are looking out towards the airplane, which just happens to be very nearly in the same line of sight as the moon. Now, if we're exactly in the same line of sight, it would pass right in front of the moon, wouldn't it? But it's close. Well, most of the time when two planets pass each other in the sky, or the moon and a planet get close together, they're not exactly along your line of sight, but very, very close, close enough so that it makes a very beautiful sight. And you want to take your camera out and get a whole bunch of pictures of it. Anyway, that's a conjunction. Here's a conjunction on a grand scale, right? These are the ones that we see amongst the planets and the moon. Here we are on our Earth, right there. And our solar system, I'm so grateful for this. The solar system is like a pancake. It is pretty doggone flat. Not perfect. The planets' orbits are a little tippy this, a little tippy that, but it is relatively flat. And as we look across the solar system, usually we'll see a planet over here, and then we'll look this way and we'll see a planet over there. We'll look this way and see a planet there. But every so often, from our perspective, as we look across that solar system, we see two planets in a line with us, just like that airplane in the moon. And that's what's happening with Jupiter and Saturn. Jupiter is closer to the sun by about 500 million miles. Saturn is further. Jupiter travels faster because it is closer. Saturn slower. So what we're really witnessing here is Jupiter catching up to and eventually passing Saturn. And the moment it passes is the moment of closest conjunction. It's just a matter of line of sight, isn't it? Straight across that plane of the solar system, out all the way to Jupiter and Saturn. That happens, this big event, which is called the Great Conjunction of the two planets. That occurs on December the 21st, which, by the way, is also the winter solstice. Here's a view of the same thing, but from above. That's what we saw before. Now we're looking down on the solar system. Here's the Earth. We're looking towards Jupiter. Notice its speed here, a little faster than Saturn. About what, 8,000 miles, a little less than 8,000 miles per hour. But they're like runners on a track. That runner is going to be passing Saturn. And that's what's going to make for all of this upcoming excitement. Here's kind of the score, what's been happening since September 21st. You can measure distances in the sky, by the way, by using your little pinky, your finger, your little finger. If you take that little finger and you hold it out against at arm's length against the sky, that fingertip will cover 1 degree, which is equal to 2 full moons stuck side to side, right next to each other. Try that, you're not going to believe it. You're like, how can 1 fingertip even cover 1 full moon? But it does cover 2, which is 1 degree. Right now, you can see the distance shrinking because Jupiter, represented by the longer arrow, because it moves faster, is approaching Saturn. Closer, closer. Right now, it's about 1 degree, just a little more than 1 degree. You can go out tomorrow evening at dusk and see if you can get your finger between those 2 planets. And then go out a few evenings later, and you won't be able to get your finger between them. It's kind of fun. Anyway, they're 1 degree now, but they're going to be 1/10 of 1 degree apart on December the 21st. And that's when they're closest to one another during the solstice. That's called a Great Conjunction. Every 20 years, Jupiter, the faster one, laps Saturn. So we get a Great Conjunction every 20 years. Repeat, repeat, repeat. But because the orbits aren't always exactly squared up together, usually Jupiter goes above or below, but this time almost in front, really close. Thing is, you do not have to wait to the 21st to enjoy what's going to happen. Here is what the scene will look like on Wednesday, December the 16th, when the crescent moon comes and joins this pair of planets. What a beautiful thing that is. It'll be not quite, but almost in conjunction with Jupiter and Saturn. And if you have a cell phone, you should be able to get a picture of this in twilight. And certainly, if you own a DSLR, you can put that on a tripod and try your hand at several exposures. Very easy to shoot in twilight because there's a lot of light. And you can include a scene too, because you got enough light to show the landscape. Check this out though. Hour after sunset, southwestern sky, December the 21st. Great conjunction, right? This is an especially great conjunction because the 2 planets will be the closest they have ever been since the year 1623. That's almost 400 years. You have to go back almost 400 years to find another time when they were this close together. Now I've been asked, will the brightness of these 2 planets, will it somehow be greatly magnified because they're so close? And I would love to say yes, but the answer is no. It will look like Jupiter, and then you'll see a bright little bump on it. That'll be Saturn. And although you should be able to separate those 2 planets just with your naked eye, I encourage you to bring binoculars too, because binoculars will make it that much more beautiful. So naked eye and binocular for this conjunction. As we approach on December 19th, again, this is, if it's cloudy, there are still wonderful opportunities. Let's say it's cloudy when they're closest. But on the 19th, look, there's Jupiter, very close, tucking underneath Saturn. There it is, swinging off to the left. And finally on the 23rd, it's a little further away yet. So you've got like 4 days. Matter of fact, you've got a couple of weeks to enjoy this event. And I hope it'll be clear on that solstice night when you can see them together at their very closest. If you have a telescope, I strongly encourage you to bring it out and use it. You can see the 2 planets in a pair of binoculars, and you might be able to see a couple of Jupiter's moons. You see these little dots here? Those are its 4 brightest moons. you will see those through a small telescope. This is really unusual to see two planets this packed close together in the same field of view. That's the view at dusk, kind of a simulation for you to anticipate what you might see. We're pulling back now so you can take in the full scene that evening on the 21st. Notice the moon will be in the picture too, to the upper right. It'll be near half, which is called first quarter phase. Down here are the almost merged planets of Jupiter and Saturn, low in the southwest at dusk, approximately an hour after sunset. Let's take a quick look before we move on to our next topic at the 1623 conjunction. So, wow, that sounds great. Anybody observed this thing? I have not been able to find anyone who observed this thing because I think these two planets, although they were just as close as they are now, they were very low. See down here, this flat horizon? They were so low at dusk, just 2 degrees high, that they were lost to view. It would have been extremely difficult for someone to have seen this conjunction. So then you ask, well, what was the last great conjunction this close, like our own, that people could easily see? And that one occurred back on March 5th in the dawn sky in the year 1226. So it's really kind of an amazing thing that it just so happens that we get treated to this extremely wonderful great conjunction in our lifetimes. And I don't know when it's going to happen again, but it'll be a long, long time. So I just hope we have some clear skies, and I really hope that you'll have the opportunity to see it. Now, this time of year, it's Christmas time of year, Hanukkah. And in the Christmas story, there's always mention of the Christmas star, the Star of Bethlehem. And a number of astronomers have worked to try to figure out what this symbol of Christ's birth may have been. Could it have been a supernova? And we don't have any reports of one around that time. Could it have been a bright comet? Possibly. The most likely thing, if it is a real thing and not just symbolic, the most likely thing was that it was a conjunction of two bright planets. There are conjunctions happen all the time with the planets, but when you have the two brightest planets in the sky moving very close together, as they did here in the year 2 BC. This is a view on August 12th in the year 2 BC. We had a super close conjunction of Venus and Jupiter. Could this have been the Star of Bethlehem? Sadly, no one really knows. But we're curious, so we're trying to figure out possibilities. And this is a possibility if it was an actual physical event, a brilliant conjunction of the two brightest planets, even closer, as a matter of fact, than Jupiter and Saturn will be this December 21st. So we've talked about two events that you can see with your naked eye and share with your family and friends. You can also take pictures of them too. We've talked about the meteor shower, the Geminids, and then the approaching conjunction of Jupiter and Saturn. Now, I wanted to just sort of familiarize you with some of the other bright sights of the night sky that are out right now. We can't do a full constellation lesson here this evening in such a short time, but you can use the brightest things in the sky to guide you to some of the easier constellations. It's important, if you want to learn the sky, to find some key points to hang your eyes on, sort of, to speak, where oh, there's Cassiopeia, there's the Big Dipper. And as you become more familiar and add other figures, you become more comfortable with the sky, and you begin to understand the most confusing thing about astronomy is that the stars are always moving because the Earth is rotating. Anyway, there is a bright planet out, visible straight south at around 8 o'clock in the evening. You have probably already noticed it. It's Mars. And if you can just look up towards the south, about 2/3 of the way up in the southern sky, you'll see a bright pinkish orange star there. That's Mars. And raise your fist up, and about 1/5 to the upper right of Mars is a square of fainter stars called the Great Square. How's that for imaginative? And the Great Square is a real keystone, an important piece of the sky, a good guide for you. It's a big part of the constellation of Pegasus, the flying horse. So this is the outline of Pegasus. So you can use Mars to leap over to the Great Square and then use the Great Square to extend outward and connect additional stars to form the flying horse. And yes, it has wings just like this. And that's at around 7 o'clock in mid-December. The other site, and it is a really great site, especially when the moon's not in the sky. And I saw it last night. We went to the dog park here in Duluth, and there was a break in the clouds, and the dog park was really dimly lit. And my daughter and I could look up, and what a beautiful group of stars we saw in the eastern sky. This was at around 7 p.m. Again, early. So just after dinner, you can go out, take your kids out and see if you can find these objects. If you look up at that time, you'll see a really bright star in the eastern sky, about halfway up. That star is called Capella, and it is the brightest star in this pentagon shaped constellation. You see that? That one is called Auriga, the charioteer. It's a fellow who rides a chariot up there, kind of riding it up the Milky Way in the eastern sky every evening in December. If you find Capella and see the outline of Auriga, and it's quite easy. It's just, it almost looks like a child's house, one of those simple houses with a triangular roof and a flat bottom. Then you can jump over here to Aldebaran, which is another bright star, but distinctively orange. So it has a nice color to it. Not as bright as Capella, but a standout star. And Aldebaran is located in Taurus, the bull. Here's the face of Taurus right here. And these are his horns. That's one horn. His horns are kind of pointed downward. One horn from Aldebaran and one horn towards Auriga. And next to Aldebaran is a V-shaped group of stars, these little tiny stars. They're about 150 light years away, and they're called the Pleiades. And what they really are is a true star cluster where all the stars are physically connected by each other's gravity. They all move together in a swarm, almost like a school of fish. And it's a star cluster, and it's one of the closest star clusters to the Earth and one of the very brightest too. Real easy to see. So speaking of star clusters, look right above the Pleiades and you can't miss what always looks to me like a bunch of grapes, when you pull them out of the refrigerator and you start popping them off. That's the Pleiades, or also known as the Seven Sisters star cluster. What a beautiful sight with the eye. See how many stars you can see in the Pleiades. Can you see 5? Can you see 6? Some people, you're not going to believe this, can actually see up to like 13 Pleiades under dark skies. I know, I don't even believe it. Here's what it looks like. Not a great photo. I took this through a telephoto lens, but I was trying to get a sense of what it would look like through a pair of binoculars. So if you do bring binoculars, point them at the Pleiades, because you will see many, many more stars that are invisible to your naked eye, including what I like to call the conga line here. There it is, that little group of stars kind of drizzling off the side of the Pleiades. This is a great sight. It's absolutely beautiful. You see anything here that you recognize? Take a look. Yes, well, there's Aldebaran, there's the Pleiades, and of course, there's the belt of Orion right there. And up above the belt is Betelgeuse, down below the belt is Rigel, and this box here is kind of the outline of the main figure of Orion, the hunter. This is around 9 o'clock in mid-December. You can see those other scenes early at 7. But if you want to see Orion, it's best to wait at least in December until around 9, till it gains some altitude. Let's add in the line, shall we? My friends always say, Bob, I can't find these constellations because there's no lines up there. If there was just lines, or especially if there were figures like you see here, it'd be so much easier. Well, I can't disagree. Here's Orion. Now you can see that he represents a hunter. Betelgeuse is in his shoulder. Fainter stars outline a club. Here's his shield, or sometimes he's seen carrying a lion's pelt. And then this is Orion's belt right there. And below his belt, you can see faintly his sword. Take a look here in a pair of binoculars too, and you will see a beautiful little fuzzy cloud. That's the Orion Nebula. It's like a star factory. There's just thousands of stars being born inside that little bit of mist that's located 400 some light years away. And here's Gemini. If you see the belt and you see orangey pink Betelgeuse, then you head off to the left or further to the north and you will find Gemini. And this is where the meteor shower comes from. So you can kind of use the shower to help you find Gemini. During the time you're out laying in that chair, you can identify Orion, work your way up to Taurus, the Pleiades, Auriga, and Capella, and then look way off to the south and you'll see the planet Mars and perhaps be able to spot the outline of Pegasus and the Great Square. I'd like to, before we end the presentation here, and I can answer any questions you might have, I wanted to let you know that although I'd love to be by your side with my little laser light and be able to point out the stars to you individually, and I have to be honest, I really do miss that with people, that kind of teaching. You can do this on your own. If you don't already have an app for your phone, this is one that I can recommend. It's free for both iPhone and Android. It's called Star Chart. And all you need to do is Google iPhone Star Chart app and then download it, or Android Star Chart app and download it and then install. And it works really good. There's not ads and anything like that on it. So they occasionally ask for money or something, but you can upgrade, of course, to a different version as well. But this version works great, Star Chart. When you do get this, one little tip I'm going to give you is that you will be happiest if you, after you're done downloading, you put it into the settings, you click on the settings for the app, and you go in and you'll see something called night mode. Just click on night mode and that will turn your screen red. And red's important because it will preserve your night vision. You don't want to look at a bright blue screen at the sky because you won't be able to see the stars clearly. But you can look at a red screen and your eyes will still remain well dark adapted. So go to night mode and switch that out. One final thing I wanted to share with you, besides the app is great. You can use it anytime, shows the planets, shows the constellations. You can travel into the past and the future. You can simulate the conjunction. You can do anything on that thing. So be sure to check it out. You can also get this at skymaps.com. There's a free evening sky map that you can print out. Go there at the end of each month or the beginning of the month, the new month, and download this and then print it out on your printer. It shows you a simple map of the constellations. It identifies where the planets are. And it also has a list of events that you can see, naked eye. So this is very handy. And I also will always feature any kind of interesting event, whether that's the Northern Lights or a planetary conjunction or a meteor shower. I'll always do a blog on it. And you can just look up my blog at any time by typing in Astro Space Bob. I like the space part because that's mostly what's in my brain is outer space. One final thing, you may have heard that there was a great shot at seeing the Northern Lights last night. There was an explosion on the sun called a coronal mass ejection, and this thing just went flying out towards the Earth. The space weather forecasters were all psyched up, predicted a strong geomagnetic storm, which usually brings a pretty good aurora. Unfortunately, when it arrived at the Earth, it wasn't these big clouds of particles that the sun blasts out. It carries with it some of the sun's magnetic field, just like a magnet. You know, it has a north pole and a south pole. Well, astronomers can't predict whether the north or the south pole is up or down in this big cloud. If the south is up, it will find a way to break into Earth's magnetic field, kind of like fingers going under your collar, and it will connect to our magnetic field around us, the same thing that directs a compass. And the particles will stream down at extremely high speeds into the atmosphere, and we'll see the northern lights. But if north is that way, north will not connect. So you never know which side is coming. There's a chance, however, even though we missed the storm last night, there's a chance for a minor auroral storm this evening. So if it's clear after you're done listening here, take a look out, allow your eyes 10 minutes to adapt to the darkness, and see if you could spot maybe a little glow on the northern horizon, the remnant from this explosion on the sun that hopefully, we hope tonight, linked up with our planet to create a little display of the northern lights. That's the end of our my presentation this evening. I hope some of these things were of interest to you or helped your understanding. And I'm available now for questions if there are any.
Great, Bob. We've definitely had lots of questions coming in and lots of compliments. Thank you so much for sharing your knowledge with us.
Oh, sure. I love it. And it's so nice to have people be here and interested too. I wish I could see all your faces.
There's a good 170 people following.
Great.
So, yeah. All right. Lots of good questions. So from Mary Welcome, do all asteroids and comets eventually turn to dust and disappear?
Comets are made of ice, and they will eventually, well, they have to go around the sun many times before, and it depends on the comets. Some are a little bigger, some are smaller, but eventually they do crumble apart and vaporize. Mm-hmm. Asteroids, being made of rock, hold together better, and they do not generally crumble. That particular asteroid, because it passes so close to the sun, is in an extreme situation. Most of the asteroids we know of are in the asteroid belt between Mars and Jupiter, and it's chilly out there. So they're going to go around. They've been going round and round since nearly the beginning of the solar system, and they'll be around a really long time. Good question.
Got it. And you pretty much answered this, but are there any other important differences to know between asteroids and comets?
Yeah, and there are some asteroids that are actually burnt out comets. They've used up most of their ice, and what they are fragile bodies of leftover goo stuck together. So you can have some comets kind of evolve into asteroids, but generally comets are quite small. They come from very far out in the solar system, beyond Jupiter, beyond Neptune even. And they're made of primarily ice, whereas asteroids are not always, but primarily rock, especially the inner asteroid group. There's another outer asteroid group that's made of ice and rock.
Let's see. Jennifer asked, can we see any of the rings of Saturn as the conjunction occurs?
With a telescope, you can. You need, I think, a 3-inch telescope. You don't need a big scope. That's what's so great about Saturn's rings. You need a minimum of 30 to 50x, 50 times magnification, and a telescope that's at least 3 inches in diameter. So the lens on the end of that thing is going to be about this big. And you will definitely be able to see the ball of Saturn with that, and you'll see the ring cutting through it. And then you'll see Jupiter's moons too, very easily. Jupiter's moons are bright.
Hey, put it on your letter to Santa telescope.
That's right.
Please arrive before December 21st. So.
Good luck.
Yeah. Oof. Let's see. Someone anonymous says, this is a simpleton question, but I think it's a good one. Do stars have a revolution like planets?
Stars do, well, revolution and rotate. Stars do spin on an axis, so they do rotate. Matter of fact, the sun spins on an axis once approximately every 4 weeks. But stars don't revolve around other stars unless they are already in a pair as a double star where they're gravitationally connected. Instead, what stars do and what the sun does, because it's all alone, right? The sun, They revolve around the center of the Milky Way, where there's a great mass of stars and gravitational pull. So stars do revolve, but they revolve around the center of the galaxy. Good
Okay.
question.
See,
Not
not a simple
simpleton.
question,
Totally
anonymous
great.
attendee.
They're all, yeah.
All right. Oh, very important question. What's your favorite planet?
Earth. No, not really.
Good answer.
I really love this place. I think my favorite planet, like to look at in a telescope. Oh my gosh, I think it's Jupiter really, because Jupiter's big enough that you can really see some stuff going on there. It has colors, it has the red spot. You can watch the moons eclipse each other and stuff. I'll say Jupiter.
All right. We won't tell the other planets.
Especially not Pluto. Don't tell Pluto.
I was going to say, there's another question. Do you have feelings about Pluto that you'd like to share?
I can't go to bed at night sometimes because of my feelings about Pluto. Do I have feelings about Pluto? I understand why people are upset that it was demoted as a planet. It wasn't. Normally the International Astronomical Union doesn't take votes on these sorts of things, but I think they felt compelled because astronomers were discovering other bodies that were similar in size and distance to Pluto, and they had to make a choice and call them something. And they all started to look like asteroids more than they looked like planets. And so they decided to change Pluto's classification from planet. They didn't just make it an asteroid. Okay, they went halfway between planet and asteroid, and they call it a dwarf planet. So they created a separate class for Pluto and 4 additional objects out there, and they call them dwarf planets. And as far as I'm concerned, I think it's just all words to me. I'd be happy to have Pluto back as a planet.
All right. Well, at least they let it down easy.
Yeah, they tried to, but I still think there's a sense of being offended.
I think our kids will wonder why we have strong feelings about it.
Well, you know what our kids are going to do is they are going to reclassify everything down the line. You know that's going to happen, right?
Because there's certainly plenty more to learn.
Yes, there is. It will fit into some broader classification one day.
All right. Oh, Judy McDowell, great question. I noticed in the diagram that Jupiter and Saturn orbit in the opposite direction of Earth. Why?
I think they orbit in the same direction as Earth. It's just that in the diagram, the arrow for the Earth was put on the right side of its orbit, but the orbits, all the planets orbit around the sun counterclockwise.
Okay.
So if you were to shoot up above the plane of the solar system in a spaceship and look down over the North Pole of the Earth, you would see all the planets orbiting counterclockwise in that direction. So, okay. Yep. So all the same. Absolutely all the same. Sorry if there was any confusion in that. I apologize.
No, that's a great clarification. Do you know if there's folklore or legend or traditional belief about the great conjunction that's coming up?
I think just contemporary, because it's happening around Christmas, I think, and I think it's wonderful that we do this. I think we can associate it with Christmas, and some people may want to associate it with the biblical story, or maybe even make a solstice connection with it too, because of the timing just happens to fall on the very first day of winter. But culturally, that's just a very interesting question. I'm not aware of culturally how it fits in, because a close one like this happens so rarely. As I said, the last time was almost 400 years ago, and almost nobody saw that one. So that is a good question. I don't think I can completely answer.
Really interesting to look into that. If anybody finds anything out, shoot us an email. That'd be really interesting to hear.
I think contemporary culturally will make something of it. It sort of, it can fit in. So anyway, sorry.
Maybe it'll fix the pandemic, right?
No, it is occurring at the same time that the vaccine becomes available.
Exactly.
No, this will become an association, right?
Great. Yes.
That's often how we are as humans. When two things happen at the same time, whether or not they're actually related, we tend to relate them in our minds.
Yeah. All right. You talked a little bit about the iPhone and Android app that you recommend for night sky or planet. Are there any other websites besides your blog that you might recommend?
No, there's no other websites at all.
Bob covers it all. It's all you need.
No, there's just a ton of websites. And if you read my blog, I will always link you to what I think are useful websites for you. I can tell you right off the top of my head, if you are interested in purchasing a telescope, there are a couple of good websites for that. There's a website called telescope.com that you can go to, and they have all different kinds. If you're interested, and maybe we could do a telescope thing sometime, but a very nice telescope is called a 6-inch Dobsonian reflecting telescope. And you can see everything with this telescope, and it costs right around $300, and it will last your whole lifetime. That's all you'll ever need. And one of those models is available at that telescope.com website.
Hey, how about a more analog book that you might recommend?
Well, you could. I have a book that I wrote myself about the night sky called Night Sky with the Naked Eye. And you can get that on Amazon and Barnes and Noble and Indie Books.
And at the North House School Store, I believe.
And at the North House. Thank you. Yes, Jessa, thank you for reminding me.
I hope I'm right about that. Usually, yes.
That one is all about naked eye astronomy, so I could recommend that one.
That's a great choice. All right, lots of good little notes coming in. Can you talk about the prediction of northern lights? You addressed that a little bit, but how do people predict that?
Yes, I just saw somebody had mentioned The Stars by H.A. Reid. That's another wonderful book. That's kind of a classic that's been around for, I think, more than 50 years, and it's about constellations. So that's a good one if you really you want to learn about the constellations. So the question again was about predicting the northern lights.
The northern lights, yeah.
Nowadays, you can go to various websites, and you can even subscribe to a regular email from NOAA, N-O-A-A, and they will send you 3 times or 4 times a day an update on the current space weather conditions, what the prognosis is for a northern lights display. And when you learn the code, which is called the KT index, you can look at one of these little emails and go, hey, this looks like a good chance for northern lights. There are 2 main sources for northern lights on the sun. The one is if there's a solar flare that sets off an enormous explosion that powers a cloud of subatomic particles into space, number one. The second one is when there's an opening. It's like a giant crack in the sun's corona. That's the glowing thing you see around the sun during a total eclipse of the sun, called a coronal hole. And when a hole happens in the sun's corona, particles can stream out fast and furious, and that can also cause northern lights. So, and all of that information is available at these different websites. And I periodically update my blog with those websites. So if you're a regular reader, you will see those sites and you can learn how to subscribe to them.
And remind us how to find your blog.
Just type in Astro Bob in Google, and you'll find it there.
Wonderful. All right, we have time for just a couple more questions. Why is my astrological sign not visible on my birthday?
Let's see. I think that's because you mean not visible at night, right?
Right.
Right. It's because the sun is too close to it. If the sun, right. The things that are visible at night are they're off from where your sign roughly is where the sun is. So that means you can't see that constellation. It's lost in the solar glare. So it's too bad. It would be nice if your astrological sign were the constellation that were rising when the sun sets, because then you'd be able to see it all night, right?
Be handy, yeah.
Very handy. But the sun is in your sign or near it, so you can't see it.
Ugh, a flaw in astrology. Who knew? Let's see. We have one or two more questions. Tips for taking photos of the night sky.
The best thing to use is a DLSR, just a digital camera, a tripod. And the key thing about getting pictures of the night sky is focusing. This is kind of the tricky part. Once you learn it, super easy. You can't use autofocus on stars. You have to put everything on your camera in manual. And then you point your camera at a bright star and you use your live view button on the back of the camera, press that, you enlarge the image with the little magnifying glass, and then you manually focus your lens on the star. Once you're focused, you're good for the night. Then you compose your picture, set the ISO to 1600 approximately, maybe 800, and open the lens up all the way to let in the maximum amount of light. So click that barrel so it reads 2.8 or 3.5 or 4, and then do 30-second exposures. And look at the back of the camera after the exposure. And if it looks like you're close, good. If you need to add more time or increase the ISO number, make it more sensitive to light, do that. But the main thing is a tripod, focusing in manual, setting your timer to 30 seconds. That's usually what most digital cameras stop at, 30 seconds time exposure. And then just composing and shooting and looking at the results and working from there. I hope that helps.
If you didn't get that all, this webinar will be posted so you can watch it again at your convenience at northhouse.org. It might take us a day or two to get it up, but it'll be there so you can go back and take notes on that. Yeah, let's see. Can you review why all of the planets orbit in the same direction around the sun? A question from Olia Wright, watching in Grand Marais, Minnesota.
Oh, that's a nice question. Yeah, it has to do with it's a super profound question. It has to do with back to the origin of the solar system itself. It's just started out as this, everything starts out in the universe as some cloud of gas and dust, you know. But the dust and the cloud isn't just sitting still. It has a slight turning motion to it. It's in motion. It's moving. As what happens in these clouds is that they begin to collapse due to the force of gravity, which gathers material together. And as the cloud collapses, it starts spinning faster. So if its initial spin is a little like this, or it could be this way, as it collapses, the spin increases. And as the spin increases, the cloud flattens and flattens. Picture yourself as an ice skater doing a spin. You can just feel the force trying to pull you out. Well, that force, because it's a cloud and it's not a solid object, it flattens. That's why we have the flattened solar system. And that's why the spin that we began with, that started it all, is sort of stamped into the revolution of the planets around the sun. They get their revolution and their momentum from that initial cloud that collapsed to form this pancake of the solar system. I hope that helps you understand.
That makes a lot of sense. That's a great explanation. Okay, last question here, and then we'll wrap up. Can you talk a little bit about the impact of more and more satellites being sent up into the sky?
Well, there's been a lot of discussion of that, hasn't there? Especially with the Elon Musk, the SpaceX Starlink constellation. It's called a constellation when they send up a whole boatload of satellites like that.
So that's logical?
Yes. I think they've got planned like 20,000 or more. And they're going to create a kind of a web in the sky where people can get the internet in various places of the globe. That's basically what it is, going to offer very fast internet service. So the problem with it is, of course, for astronomers is that they're taking all kinds of data and deep exposures of the sky, and these satellites can truly get in the way of that. So it can take away from that data and the study of the sky. If you're an observer and you just like to look at the night sky, the effect of too many satellites is to sort of industrialize the night sky experience. And I know a lot of people are having a problem with that. I realize that the Starlink satellites are striking to look at. the way they look like a train of lights in the sky, exactly in a row. But so many of those can be a problem. What SpaceX is doing is darkening them and reorienting them so that they're not as bright, but they're still there. If I don't see them with my eye nearly as often as I did a year ago, I do see them through the telescope still. So it's an issue. My great concern is not just SpaceX, but other internet providers are going to want to do the same thing. And I do believe that it ultimately will take away from the night sky experience, that sense of wilderness that is one of the grandest things about the sky, and what I find most inspiring, that it's just untrammeled wilderness up there still. So yes, I understand your concerns. Absolutely. Thanks for bringing it up.
I do want to highlight really wonderful news that our own backyard, the Boundary Waters Canoe Area Wilderness, which is federally protected public land that belongs to everyone, has just been designated a dark sky sanctuary, which is amazing. Yeah.
Are you part of Voyagers then? Is that all
I'm
part
not sure. I'm not sure. Yeah, if it's all one big dark sky sanctuary or not, but it's really exciting. We're thrilled about it. And we really hope that this summer we're able to have Bob back in person teaching at North House. Fingers crossed. Bob teaches an awesome class where you meet in the classroom ahead of time and do some lecture and some questions, and then you take a break and meet later after dark in the summer, which is late, at a place where there is there's an opportunity to do some really wonderful star observation with the naked eye, and Bob brings a telescope because we're so close in Grand Marais to that awesome dark sky sanctuary. It's a huge resource. So hopefully we're able to offer that this summer, right, Bob?
I would love to.
Great. And if I can talk him into teaching an online class, folks, I will. So.
Yeah, just for one thing, I see various comments coming up, and I just want to say thank you to the people who have been leaving little comments on the screen. You're very kind, and I really appreciate it. Thank you all.
Wonderful. We will host our last Thursday night webinar of the year. Next Thursday, it'll be a storytelling webinar with Terry O'Brien called North of Nowhere. And it'll be a series of stories and readings regarding North in the winter and the winter solstice, because we'll be very close to that darkest night of the year. So I hope folks can join us. You can register for that, as well as a whole plethora of really cool online classes at our website, northhouse.org. We thank you all for joining us and for supporting the school, and can't wait to welcome you to our campus, hopefully soon. So take care, everybody, and have a great night. Get out and look at those stars. Bob, thanks so much.
Thank you for having me. I really appreciate it, Jessa. And clear skies, everyone. Keep looking up.
All right. Good night.
Good night.